Section 7.2, Law of Cosines. In the previous section, we covered law of sines. And we noticed how law of sines help us to what we call solve for a triangle. For an oblique triangle. Means it's not a right triangle. We can't use SOHCAHTOA. It's an oblique triangle. So law of sines was a good tool for us to help us find missing sides and angles in the triangle. And then we noticed in some applications in the previous section how it helped us to find, let's say, like the height of the building or the length of a side, that distance from a point to another point, and so on and so forth. So this was, we see a lot of applications to that in the previous section. Now the question is, what about if we run across a case, say the three sides are given. So this is a given case. So let's say we have triangle ABC, ABC. So let's say, just randomly, let's pick a number 4, 6, and 7. So if we try to use law of sines, by law of sines, sine A, I don't know A, but I do know small a 4. I don't know B, sine B, so but small b is 6. And then sine angle C over C. C here is 7. So with this, there's no way we can solve for any of the angles. Although you know A plus B plus C, the three angles, their measure add up to 180. But that's still not enough. You need at least one given angle. That's why law of sines doesn't work in this case. We need a different tool. Different tool is the law of cosines. So what does law of cosines say? Law of cosines say that if we have a triangle ABC, like the one I drew earlier, ABC, so it says that a squared, let's say I want to start with a squared is b squared plus c squared minus 2bc, so 2 times the length of b times the length of c, cosine the angle that is facing the first thing that we start with. So if you start with a, you end up with a. Same thing happens with b. So b squared is a squared plus c squared, looks like the Pythagorean theorem, minus 2ac cosine the angle that is facing the first side that you started with. Or c squared is a squared plus b squared minus 2ab cosine the angle that you started with. Here we got, I have a b, and then c. So we have all these three angles and three sides. So now what we need to do is look at an example, how we apply law of cosines. If I go back and take an example, let's say I want to solve for one of the sides. Let's say this angle is 30 degrees angle, or let's make it 60, and this is 4, 6, and we would like to find x. So with this one, if you try law of sines, sine 60 over x equals sine the other angle over 60 equals sine the third angle over 4. It's not going to work out. So law of cosine will do it by starting with x squared. That's the one I'm looking for. Is 4 squared plus 6 squared minus 2 times 4 times 6 cosine the angle that is facing x, which is 60 degrees. So you get x squared is 16 plus 36 minus 48. Cosine 60 is 1/2. So you get x squared is 1252 minus 24. So then x squared is 8, and 4 minus that, 28. So if I want to find x, we just do square root of that. And that's why we have a calculator on the right side to help us find out what the square root of 28 is. So we're going to go square root, oops, what is 0? Square root of 28. That gives us about 5.29. Approximately to 2 decimal places. So that's the law of cosines. Now just keep in mind, if we are required to find more angles, more sides, like solve for the entire triangle, always avoid using the law of cosines more than once, because as you could see, there's a lot of work involved in here. So let's say I want to finish solving for this, though this is about 5.29. Then you can use law of sines. Now law of sines will work out. Call this like alpha and beta, and then you will be able to find alpha. by doing sine alpha over 6 equals sine 60 over 5.29. That will give you alpha. After you find alpha, then you use alpha plus beta plus 60 equals 180. Don't use law of sines. So it works out in a way that first, the hardest is law of cosines to use, because there's a lot of steps and work to do. Then, after you do one side, find one side, use law of sines, or one angle, law of sines. And after you use law of sines, you can use the fact that a plus b plus c is 180. That makes it much easier. Of course, you can use law of cosines more than once or law of sines, but it's just time consuming. Now let's look at an example of what about if they ask us to solve triangle ABC if A is 7, B is 8, and C is 10. So they give me three sides now. So what you can do, you can label this on the diagram if you like. Or before you do that, look what I'm going to do. I'm going to write the law of cosines. Where should I start? A, B, C, or which one should I go with? Well, you can start anywhere because they're all given. The sides of all of them are given. I'm looking for the angle. Let's say I want to find angle A first. So I'm going to use this. A squared is B squared plus C squared minus 2BC cosine A. So what is A here? A is 7. So let's substitute. Wait, we're not going to substitute. You can, and you can solve for it. But before we do this, this is what I'm going to do. I'm going to subtract b squared on both sides and c squared on both sides. So b squared and c squared. That gives me a squared minus b squared minus c squared equals negative 2bc cosine A. We don't like to see negative on the right side here. I'm going to multiply by negative. So that would give me b squared plus c squared minus a squared equals 2bc cosine angle A. Then we're going to solve for cosine A. So cosine A is b squared plus c squared minus a squared over 2bc. So that's what we have. This gives me a formula for cosine A. So if you want to find cosine A, you don't have to do all this work again. The way to memorize it is think about the Pythagorean theorem. If it starts with A, do the other one squared, b squared plus c squared, and then divide by 2 times their product, and then always minus the other side square. So there's always minus here, and A matches A. That's how I memorize it. So can I mimic this and kind of like write it for B? Yes, you can, and I'll show you that in a minute if you like. Or we can continue with the problem. Let's maybe write that down for the B and C. So cosine B would be a squared plus c squared minus b squared over 2ac. And the next one, cosine C, is a squared plus b squared minus c squared over 2ab. The three of them. These are the three of them. So if I want to go back and find cosine A, so I'm going to rewrite this again. Cosine A is b squared. B was given to us as 8. So 8 squared plus c squared. C is 10. So 10 squared minus 2 times, minus a squared, which is 7, over 2 times 8 times 10. Okay, so then cosine A equals, let's put that in the calculator. That's the top one is 8 squared 64 plus 10 squared is 100 minus 7 squared is 49. All that is being divided by 2 times 8 times 10. So that gives us about 0.71875. Now if I want to find what angle A is, so angle A is cosine inverse of that number. So what I'm going to do is I'm going to make sure the mode is degrees. It's not here, so I'm going to change it to degrees and quit. Now I'm going to do cosine inverse of the answer. So I'm going to go second to the negative sign. So what it does, it copies the previous answer and pastes it in here. So that gives us the angle A. So A is about 44 degrees. Let's say 44 degrees. So I found angle A. Now, can I find angle B using the same formula, just, law of cosines? Yes, you can. But remember, if you start with the law of cosines and you want to find the next, use law of sines. Sine A, which is 44, I just found it, over side A was given as 7 equals sine, let's say I want to find B. and B was facing side 8. So now we cross multiply 7 sine B equals 8 sine 44 degrees. And then sine B is equal to 8 sine 44 degrees divided by 7. And then what we can do, we can put all of this in the calculator. Okay, all this in the calculator. And or what you like to do, if you like, you can find angle B here is equal sine inverse of all this quantity, 8 sine 44 divided by 7. So angle B is gonna be equal about to, let's see, sine inverse of 8 sine 44, close the parentheses, divided by 7, close the other parentheses. Oops, maybe I duplicated. Yes, I have more than what I need, parentheses wise. So sine inverse again, 8 sine 44, that closes this parentheses, and then divided by 7 and close the big parentheses. So that gives us about 52.55 degrees. That's angle B. Now to find C, angle C, is 180 minus the sum of angle A and angle B. So angle C is going to be 180 minus, this one we found it 44, and this one we just found it 52.55. So 180 minus the sum of 44 plus 52.55. What does that give us? So angle C is about 83.45 degrees. So what I did, they give me three sides, and I found the three angles. So what did I actually work out here today? I worked out the first case that I worked out here. This was what we call SAS case. So SAS case doesn't work with law of sines. So we need the law of cosines. And the next one I did here, this is the SSS case. So it doesn't work. The SSS case, it doesn't work with law of sines. So we have to use the law of cosines instead. So that's what I did here. Okay, so that's what we have so far. We got all the angles, the three angles that we needed, and based on the given information they gave us. So now let's see where can we apply law of cosines even more as an application, not just to solve for triangles like this. To do this, we're gonna introduce see how we apply it in navigations. Let's introduce navigation. So we introduce the first definition, which says that the heading of an object, so that's the definition of the heading. So the heading of an object is the angle measured clockwise from the north or due north to the terminal side of the path, which is not affected by the current or wind or anything else of the object. So that's called the heading. And then when I draw the graph, you're going to see what that means in a minute. So that's one thing. So the heading is the angle that is formed by the north side or the north direction or the north side and the terminal side, and you will see what that terminal side in a minute. And also we need to introduce, of course, this thing is called just the path. We call the path. If that path get affected by either the wind or the current or anything else, then it's called the actual path. And I'll show you in a minute what that means. What's the actual path? So for the meantime, we introduce again also another definition is called the true course. The true course of an object is also the angle formed from the north to the actual path of the object. That's called the true the true course. That's called the true course. Now On the top of this, before we show you graphically what that means, we also introduced the airspeed and the wind speed. In a minute, you're gonna see them, three of them: the ground, wind, and the airspeed. The airspeed is the speed of the object relative to the air, and it's really representing a vector, velocity vector, in the direction of the true course. Again, all this might sound complicated, but as soon as you see the graph, you will get the whole thing. And then the other one is the ground speed. The ground speed is the speed of the object relative to the ground. And the wind speed is the magnitude of the vector representing the wind. So let's see, what I did here is we use a lot the true course heading, airspeed, ground speed, and the airspeed. So usually the way I memorize it, always the true course goes with the ground speed, and then when it ends up with the path, and the heading always goes with the heading always goes with the, no, this is the actual path. The heading always goes with the airspeed, which we call it just the path. So let's see graphically what that means. I want to again recall the law of sines, which states that sine A over A equals sine B over B equals sine C over C. Just keep that in mind. We might need to use it here in this section, as we did earlier. So let's say, so the way I draw this, so we draw like a vertical line, that's kind of the north, and this side, this angle here, this is the airspeed vector. This is the airspeed vector. So the angle formed by the north side and the airspeed vector is called the heading. That's what the heading that we introduced earlier. And the next one, if we have the north again, and here we have the ground speed, this angle here, so that's the north. This angle here is called the true course. This angle is called the true course. Okay, so that's how these things are related to each other. So now let's in general draw like a north direction or north course like that, and then let's say I would like to draw the same vector, the airspeed vector, airspeed. Again, this would be the heading. This would be the heading, that's the north. And now let's say there is a wind coming from somewhere, like say this way. That's the wind speed vector. So that's the wind speed vector. Okay. If we take, let me get this all the way here. If we draw another north one, another north direction, this in this case is called the wind direction. This gives me the wind direction. This is the angle formed by the north and the wind speed vector. But we are concerned more about the ground speed. The ground speed. So what is the ground speed? The ground speed is going to be, in this case, because the airspeed, this airspeed vector that I drew, is affected by the wind. So it's gonna shift it down or up, or depending on the direction of the wind. So then what happens is the point where we started here and where this ended, this is called the ground speed. That's the ground speed. And the angle from the north all the way down to the ground speed, if you remember, like if I scroll back up, see ground speed and north, ground speed and north, it's a true course. So that's called the true course. That's the true course. So that's what we have here. We need to learn what is the airspeed and what is the ground speed, and how do we find them if we are asked to do so. Another thing I want to recall back from geometry is if we have two lines, parallel lines, let's say, cut by a line, another line, that line called transversal. So then if we have a Z letter like this, Z, this angle here, this is A, this is A. This is called alternate interior angles. They come like Z, backwards Z, upside down Z, flip Z, whatever you want. As long as it looks like a Z letter. Those are called the alternate interior angles. And if we call this B, this angle here and this angle together are called supplementary. They add up to 180 degrees. So sometimes we use this when we do navigations, airspeed, and things like that. Those are important to know. Let's look at an example. So let's say we have a plane. A plane is flying with an airspeed. Of 190 miles per hour with a heading of heading means an angle, right, of 110 degrees. The wind currents are running, so there is a wind existing, is running at a constant speed of 35 miles per hour at 135 degrees. That's the angle of the wind clockwise from due north. We are asked to find the true course. Find the true course and the ground speed of the plane. This is a very interesting question because it has two things that need to be done. First is you think about it in real life situation, what happens, how they monitor all these flights, and the other thing is we're going to see how we can use trigonometry to really solve such a problem. To be able to solve a problem like this, you need to sketch the diagram. There must be a diagram here. So let's see. It says the plane is flying with an airspeed of 190 miles per hour. So with a heading of 110. So let's say, it started here, this way. This is 110 degrees, 190 miles per hour. This is due north. As you can see, now after this, the question said the wind currents are running at a constant speed of 35 miles per hour. 35 miles per hour at 135 degrees clockwise. So you can think about it, as I said, there is a wind coming this way. Let's say this is the north again. This is the angle 135 degrees. So 135 with the north. At exactly the tip of this one. Let me rewrite the 190 here, maybe inside. So this was 190 miles per hour, and this one here, it's given as 35 miles per hour. So what do they want us to find? Find the true course. Well, what is the true course? Let's see. The true course, if you look at this, is where the plane started all the way to the ground speed. And where's the ground speed? Is where the heading here, from the heading to the tip of the wind speed vector. So it's gonna be from this point to that point. So it's this one. So this is the true course. We can label it. What is this angle here? That's the true course. So the true course in this case, is 110 degrees plus angle alpha. plus angle alpha. Okay, so true course is 110 plus alpha. So if we can find alpha, then we find the true course. Now the other thing they said, the ground speed. This is the ground speed. So we need to find this ground speed. What is going to be? Two things. Let's see what we have. If I want to use law of sines, what do I know? I want to try to find, so I know this side here is 190 and this side here is 35. So I know these two sides. I don't know this. I'm going to call it x. That's the ground speed. So that's x. I don't know this. That's an alpha. How can I use the angles 135 to help me? How can I use that? Let me erase this part. How is that going to help me to find this angle, for example, in there or something? So if I do it on the side, none of the angles given and one side is missing. There's no way by law of sine or law of cosines to work out. So I need to take advantage of the 135. To be able to find the angle inside, call it beta. How do I find angle beta? I only know 135. Remember, these two sides, the vertical sides are north. Both of them are parallel lines. So if this angle is 110, this angle should be 70 because they are supplementary, based on what I just recalled. So if that angle is 70, I can take 135 plus 70, and that gives us 205 degrees. But we know the entire thing, the entire circle is 360. So 360 minus 205. If you subtract them, that gives us 155 degrees. So this beta here now is 155. So now maybe I can find something. Look, I can find x by law of cosines because it's side angle side case. So it's side angle side case. We can say that x squared equals 190 squared plus 35 squared minus 2 times 190 times 35. Cosine the angle between the two vectors, which is 155. And now we are going to put this in the calculator. First, the way we do it, we just calculate the 190 square plus 35 square minus 2 times 190 times 35, and then we do cosine 155. And that gives us this number, and then we're going to do the square root of that. So the square root of the answer. So x is about 222.21 miles per hour. Miles per hour. That's the ground speed. After we found this, remember I need to find the true course. So what is the true course? I need to find alpha. How do I find alpha? Remember, I used law of cosines. Try not to use it again. In the same triangle, we can use in same triangle, use law of sines. So sine alpha, that's the one I'm looking for, over the one was facing that is 35 equals sine the angle 155 that we found earlier over the side I just found 2.21. And then we're gonna do cross multiply. So 222.21 sine alpha equals 35 sine 155 degrees. Sine alpha equals 35 sine 155 degrees over 222.21. So then if I want to find alpha, I do sine inverse of 35 sine 155 degrees divided by 222.21. So that gives me sine inverse 35 sine 155 divided by 222.21. Close the big parentheses. And that gives us a small angle, very small angle. So alpha is about 3.82 degrees. Then the true course is given by 110 plus alpha. So it's 110 degrees plus the 3.82 degrees. So that gives us 113.82 degrees. So I was able to use trig, specifically law of cosines and law of sines, to find the true course of the plane and the ground speed of the plane. Very interesting examples and applications overall.